Welcome back to tutorial series. In the previous video, we learned how to solve questions which have unit step functions. Now let's learn how to solve when you have unit impulse function. So what is an impulse? Impulse is something like a great change or large amount of change happening for a short period of time. Similarly, the unit step function delta of t minus a is defined as delta of t minus a is equal to infinity when t is equal to a and 0 when t is not equal to a. You can observe the change only when you have t is equal to a. This is your sample graph. At the point t is equal to a, the function is increasing to infinity. So such that you have the integration 0 to infinity delta of t minus a into dt is equal to 1 where a is greater than or equal to 0. So its Laplace transform is given by Laplace transform of delta of t minus a is given by e to the power of minus as. Here's your sample question. Solve second order differentiation of x with respect to t plus 4 first order differentiation of x with respect to t plus 4 x of t is equal to delta of t minus 1, which is unit impulse function, and your value of a is 1. They've given the initial condition that x of 0 is equal to 0 and x dash of 0 is equal to 0. Taking Laplace as usual, you have Laplace transform of x double dash of t plus 4 into Laplace transform of x dash of t plus 4 into Laplace transform of x of t is equal to 4 into Laplace transform of delta of t minus 1. So you know that this is the Laplace transform for derivatives, that is s square into Laplace transform of x of t minus s into x of 0 minus x dash of 0 plus 4 into s Laplace of x of t minus x of 0 plus 4 into Laplace of x of t. So the Laplace transform of your impulse function is e to the power of minus as. Here a is 1, so e to the power of minus s. Taking all the terms with Laplace of x of t common, you get s square plus 4 is plus 4 into Laplace of x of t is equal to e to the power of minus s. S square plus 4 is given as s plus 2 the whole square into Laplace of x of t, which is equal to e to the power of minus s. Now taking s plus 2 the whole square to the denominator, you have Laplace of x of t is equal to e to the power of minus s by s plus 2 the whole square. Now you split it using partial fractions method, so which is like a by s plus 2 plus b by s plus 2 the whole square. On solving you get e to the power of minus s by 1 plus 2 s plus 2 the whole square. So on trying to take the inverse Laplace transform, you observe that you have e to the power of minus s, which means that you can make it as a unit step function. So you can use u or h. So h of t minus 1 into f of t minus 1, because you have e to the power of minus s. Now s plus 2 the whole square is of the form of second shifting property. So first you try shifting property. So first you try to take this 2 outside, because of which you get something of the form e to the power of minus 2t. And you have 1 by s square, whose inverse Laplace is t, but you have t minus 1 because of this e to the power of minus s, because this is unit step function or unit impulse function. So you substitute t minus 1 in the place of t, so you have e to the power of minus 2 into t minus 1 into, in the place of t you substitute t minus 1 again. So this is your solution using Laplace transform method when you have something like unit step function or unit impulse function. Here are a few samples. Do practice them to get better understanding. Thank you.